That's recording?
Yeah, we're on.
We're on?
Yep.
Okay, cool, thank you. So the first thing I want to do then on the metal lathe is take a step back and see if you can identify on this what looks similar to the wood lathe that we just finished talking about. So what do you see? Tom, give me something.
The headstock right there.
Sure, we've got a headstock. There's a large motor down here. There's a pulley, comes up, and we have the spindle inside the headstock right there. So Josh, what else?
The tailstock.
Got the tailstock right over here. Yep. In fact, I'm going to take these things out of that. But the tailstock is in the same spot that it is on the wood lathe. Anything else? We got the rails. We got the bed of the lathe right here. Okay. It's like a tool. Yeah. This looks like a tool rest, but it is slightly different than that. And you actually use the right name for that. We call this a tool holder on the metal lathe, and we'll see why in just a minute. What's different?
You don't have a tool that you can hold.
All right, you don't anywhere see around here a big chisel tool, and it doesn't look like there's anywhere to rest it anyway, so that's different. Anything else you see that's different?
There's a giant head for catching.
There's a giant pan underneath to catch chips, and I think I heard Hunter say there's a lot more controls on it. There's a lot more dials and levers and stuff like that, and we'll get into those here. Ethan.
You use the oil stuff.
Use what?
The oil stuff.
We've also got cutting oil here, yeah. So you know a bit about cutting metals already, and you realize that they take a lot more force to cut than wood does. And so this machine is set up to not only control that force safely, it's going to do it very, very accurately as well. In fact, on this machine we can work down to, just like on a mill, we can work down to 1/1000th of an inch, or maybe even a little bit better. So everything that you see here is designed to handle the large forces of cutting metal and also to do it very, very accurately. So let's talk about how that works. The first thing that I'll point out is that it's possible to take our bar of material, and here I'm working with a 1-inch diameter aluminum bar that I cut off on the bandsaw right there. It is possible to take this and suspend this between the headstock and the tailstock using centers, like you saw me do over on the wood lathe. So I could have one of these here, have one over the other side, like that, and grip onto it, and spin this supported on both ends. Now I guess if I was making a aluminum baseball bat, or something like that, a solid aluminum baseball bat, which probably isn't going to work very well, I could do something like that. But very often when we're working with metal, we're making smaller parts. And so it's handy to be able to hold our piece of material entirely in the spindle from one end. And that's what I'm going to do here. So I'm going to take my aluminum bar, I'm going to slide it into one of these, and then slide it into the spindle. These are called the same thing they are on the mill, this kind of shell with a little taper on it. It's a collet. So we're going to hold our aluminum bar in a collet. In fact, I think I'm going to actually flip this. No, we'll work on the same end. So now with that securely held in the spindle, turn this on. In fact, if I want to, I can even adjust the speed. And that I can go from quite slow to fast. The next thing that I'm going to do is I'm going to take the tool that I'm planning on using, which interestingly is smaller, quite a bit smaller than a wood chisel. It still has that angle on it though. It still has that upward angle. It's just very small on the end of the tool, and I'm going to put it securely into our tool holder like that and clamp down. So this is on there nice and solid. It's not going anywhere. Bar's not going anywhere. Now, of course, the challenge is to be able to get those two to contact each other. To do that, we're going to need to use some of the controls on the front of the lathe here. And I'm going to use these two right here in particular. So I wish I could give you less terminology with the lathe. Maybe there's ways that I could do that, but I do have two more names for you right here. I think that we're just about at the end. Yep. This whole big unit, this whole chunk of metal that you see riding around along the rails, that's called the carriage feet. excuse me, that's called the carriage. So if you think of it kind of like railroad rails, like train tracks, we've got a carriage riding along the rails, and so the dial that turns that is called the carriage feed. And you can see that's this big dial right down here. The second one, slightly higher up, has the effect of moving the tool across the rails, and so we call this the cross feed. Carriage feed and cross feed. So this one moves it this way, carriage feed moves it this way. So really the main thing you're doing working on a lathe is you are putting the part in the spindle, spinning it, and then you're using the carriage feed and the cross feed to move it where you want to go. And I see some people double checking with partners on that, so is there anything you want me to repeat or clarify for that? Check.
The whole thing is called the carriage, right?
So I'm moving the carriage, the whole thing is moving the carriage with the carriage feed. And then I can move the tool the other direction perpendicular with the cross feed. Move that back over here. This one right here. Yeah, I'm going to hold off on that. I will explain that one to you. I'm going to hold on just a minute on that, and you'll see how I use that. So what I'm going to show you is we're going to start with the two main operations that you can do on a lathe, and in fact, this is your safety test. Like the next thing you're going to see me demonstrate is what I'm going to ask you to do for your safety test. I'll have you guys hold up on that for right now. Watch what I'm doing here. Yep. I like how you're checking that to see, but let's look this way for right now. Here's what I'm going to do. I'm going to turn the lathe on, and the first thing I'm going to do is I'm going to take the front of this part right here, this surface, and I'm going to make that nice and smooth. And I'll do that in several passes, and that'll be the first operation that we'll work on. Spin this. I'll do probably one more.
Now it's flat and shiny.
Now it's flat and shiny. Yep, that's a good way to describe it. So what you saw me do there is you saw me use the carriage feed to move over. So I was overlapping that part slightly. You saw me use the cross feed to cut across the part. Did I go all the way across? No, for those of you a little bit further away, I only went to the middle because it rotates. I'll get the other half. And then I brought it back out, shifted over just a little bit more, did that again. Josh.
Oh, why didn't you just take it all out and go?
That much metal would have been a lot to take at once. So I actually get a better quality, I get a better surface finish on that. And it goes faster if I do it a little bit at a time like that. And if we take that out, you can see that's the surface on that. Nice and shiny, right? By the way, this is what it looks like when it first gets sawed off, so you can see the difference. That's where it would have started. Yeah. So that's the first major operation right there, is cutting on the face of the part. The second operation that we're going to do is we're going to cut along the diameter. We're going to make what's called a turning cut. We're going to make the diameter smaller. And that is basically the same steps, but kind of shifted 90 degrees. So the first thing I'm going to do is I'm going to turn this on, and I'm going to find where I am by gently touching the part to the outer diameter. I'm going to come back off the part, move in, and shave some material off. So I'm right there right now. So I'm going to move in with the cross feed a little bit. And now I'm going to go this way.
That was so good.
Yeah, you can see nice and silver now. So our goal there is probably not just to make the part pretty, although that's a nice benefit as well. Our goal in this case might be to make something that's a smaller diameter. And we can work to an exact size on that if we need to. We can work to an exact size on that if we need to, and I'll show you that a little bit later on. But those are the two basic operations on the lathe. You can take the front, and you can shave that off, you can take the diameter, and you can make that smaller. I think I want to pause there to see if anybody's got some questions, and then we'll talk about some safety issues, in particular the lathe, and we'll talk about some more advanced techniques.
You said, is it this lathe that works with basically any material?
Yes, you can use plastic on here, you can use metal on here. Every once in a while we have an excuse to use wood in here as well. Not very often.
And that one's only wood?
That would be only wood, yes. There are some specific names. There are not any that I really would need you to be aware of. What I would like you to be aware of is that the tools for the metal lathe are quite a bit smaller and look differently than the wood lathe ones do, but they still have that hook to the cutting surface. If you look very closely at the tips of these tools, there's an upward angle so that when the material rotates downward, we're slicing away that metal like this. So there's a hook to that slices away the material. And we won't worry about specific names. Okay, there's one last component, one last control on this that I would like to mention to you. So we talked about, well, actually several. Let's review these here. The power switch. Start this, it gets it spinning. It is possible to go both directions on this lathe. I can go the other direction. Yeah. So you'll need to have an awareness of which is the appropriate way to turn it. You'll also notice the speed control up here, which I've been using already. It's designed to be operated when the machine is running. And we've had that discussion on other machines. That it's actually hydraulically operated. So it sends, there's a hydraulic piston down there that helps to shift the speed. The one that you haven't seen is haven't heard me talk about, that you've maybe seen me use, is the one Carter asked about, and that's this lever right down here. And this is the clutch, really clutch and brake lever for this lathe. It's kind of an interesting feature. If I turn the lathe on, just turn it off, it needs to coast down. If you needed to shut it off quickly or in an emergency, for whatever reason, that clutch lever basically does that immediately. You notice it leaves the motor running, so I can stop, make a measurement on here, make an adjustment, and then keep going. And then shut the clutch off like that. So that's one handy thing to know. The fastest way to shut off the spindle in an emergency on a lathe that has one is to use that clutch lever. Otherwise, the power control is right here. Another rule on the lathe that's typical of most metalworking equipment is that all of the stuff you need to do with your hands is away from the stuff that actually does the cutting over there. So hands here, hands here, hands here. There's no reason you need to be in here with your hands while the lathe is running. If you need to make a measurement, say with a pair of calipers, you'll turn the lathe off, or at minimum you'll use the clutch. You'll come in here, make a measurement, and then you can turn it back on again.
Are these as dangerous as like other machines?
Great question, and actually leads right into what I was going to talk about next. Hunter asked, are these as dangerous as other machines? It doesn't really look like it, right? We just get little bits of shiny tinsel out of this. This thing probably can't be all that dangerous, right? Well, sure, the cutting tools don't have these teeth whipping past at thousands of RPMs per minute, RPMs. But this is a dangerous tool, and it comes with this thing right here, this spindle. If you remember, one of our standing rules in a lab like this is that we do not have any loose clothing, no hoodie strings, no long hair, nothing below our elbows. I am wearing my silicone wedding band right now that should pull off. Other than that, if you've got anything on there, you need to clear that with me before you use these machines. this doesn't seem like much, but there's a lot of power behind that spindle. And if anything attached to you gets attached to that, that's going to winch you in a hurry. And there's lots of horror stories related to people getting something caught in the spindle of a lathe. I'll give you one, and fortunately it has a good ending. So I went to school at the University of Michigan in the mechanical engineering program. We had a lab, a workshop with lathes similar to these. In addition to a nice engineering program, Michigan has a nice football team. They're a Big Ten program, right? They attract some pretty big people onto the football team. And one of the people in ME was a football lineman. This happened a couple years before I was in that lab as a student, but the shop supervisor told us this story. At the time, kind of the habit was you wear these really baggy warm-up jerseys or sweatshirts and stuff like that. And so for whatever reason, big guy wearing an even bigger sweatshirt, and he's leaning over the lathe like this, and somehow that sweatshirt got caught on the spindle right here and started getting wrapped around as the lathe was spinning. Now he had the presence of mind to take his hands and brace himself like this against the lathe. He couldn't reach the off switch, so the lathe kept spinning. And as that did that, it wrapped his sweatshirt around and literally tore it off of his back as it was spinning. So I tell you this story because if you think you have the reflexes and the core body strength of a Big Ten lineman, you might on your own time choose to go head to head with a lathe. I still wouldn't, and I expect you not to in this class. Keep anything attached to you well away from this thing right here.
Different things like this. What would you use?
Yeah, we're going to talk about that chuck a little bit later. But one of the things you'll notice on that is this one has lots more stuff sticking out. And in fact, if those jaws are even looser, it's got these little square knobs basically sticking out of there. And it creates many more opportunities to wrap something around that. This one's relatively clean, but it can still happen. I've seen it happen with strips of sandpaper and stuff like that. And it easily happen with clothing as well. So especially those hoodie strings, especially if you have hair, which when you lean over has a tendency to fall past your shoulder. And the absolute worst would be neckties. If you have something wrapped around your neck, dangling down in front of you, that is about as bad as it gets when you're working on the lathe. Okay, so that brings us, that kind of covers the important factors of safety for the lathe. Anything you want to have me recap at this point? So Jalen asked how I attach the collet in here. Usually what we do with the collet is we pull it in from the other side. And so on this one, there's this handle back here, which basically acts like a giant bolt on that. So we fit the collet in here, and we turn this to tighten the screw threads inside, and it pulls the collet into the spindle and holds it in place.
Is that a mechanic?
Not one that is important right now.
So that would count as like installed.
Well, so the whole unit over here, all this floor up here, this is all the headstock. It's got a motor and a spindle in it. Our spindle has a collet in it. Okay, so here's what I'd like to do in the time that we have left. I've been telling you that metalworking equipment is designed for working really precisely, but so far I haven't really bothered to do that. Did a little bit of it on the vertical mill, haven't done any on the lathe or on the horizontal mill, talking about working down to say 1/1000th of an inch. So as a demonstration of that, a little bit more on the lathe, as well as an idea of how you can work precisely with metalworking equipment in general, I'm going to duplicate this part right here. I honestly don't know what this is, but it's a great lathe demonstration part. It's round, it's got some different features on it. I'll pass it around in a minute. Except I'm going to duplicate it exactly half size. And what I mean by that is the height will be half, the diameter will be half, the hole through the middle will be half the size. I'm going to try to reduce this down to half the size of this part right here. So I'm going to pass that around. Let's take a quick look at that. Notice some of the features. And then I have about 4 copies of a drawing that I made for that part that you can kind of keep with your area of people right here. If you want more over here. And so I drew this out, and I've already done the math to make it half the size. So when I measured things with this, we're at half that size. And what I want to do is I want to see if I can do that in about 10 minutes. So This is going to take a little bit of time, but hopefully I can go through this pretty quickly, give you an idea of what that might look like. So the first thing that I'm going to do is I've already faced the front, so that front is nice and smooth. But the main diameter of this needs to be 0.875 of an inch. And by the way, has that gotten over here yet?
No, they kept trying to skip me. I have to go around.
Okay, let's not skip anyone, then let's get it over this way. The first thing I'm going to do is I'm going to take this part and I'm going to make that 875 of an inch. I'm going to do that with a pair of calipers right here. As I'm working with the lathe on, if you need to shift a little bit to see what I'm doing or trade places with someone, please be generous enough to do that. So the first thing I'm going to do is turn this on and figure out where I am. I'm going to make a cut to start off with. I'm going to measure that, because right now I have no idea what this diameter is. And coincidentally, I ended up at 975. So I have 975 right now. I need to get to 875. How much do I need to take off? I need to take off 100, 0.100 of an inch. So there is a graduated dial on the front of the machine. I'm going to set it to 0. And I'm not going to do this all at once. I'm going to take off the majority of it, but I'll probably take 3 passes total. Double checking along the way. I am at 900 right now. Okay, 125. So take 20 out of that 25. Check again. .875.5. Close enough?
No.
I'm going to call that close enough. Okay, the next thing I noticed is I have a diameter of 0.72 for the majority of this. And that goes 0.74 inch deep. So to get an idea of how far I need to go, almost like the pencil I borrowed from Josh earlier, I'm going to mark a line on here. Double check that by using the depth gauge on my calipers. I'm just a little deep, but we'll be able to fix that. 729, I need to be at 0.720. I'm 2 thousandths off. I'm going to leave it for right now. I'll tell you, a lot of times we call within about 5 thousandths to be good enough. I could take a little bit more, but I want to move on. The next thing I'm going to do is I'm going to put a hole through the middle of this. And I would like that hole to be exactly centered in this part. And the good thing is that a lathe specializes in that. Because it spins around the center, any hole that I drill in there is going to be made right in the middle. Still, to ensure that that's going to happen, I am going to start off with a small stubby center drill. You notice one of the things that we can put in the tailstock is a drill chuck like this. So we're now using the tailstock to support something else. We're using a drill chuck. I'm going to get that close, lock the tailstock gently into place, make just a little bitty divot. That's it. I'm going to swap that out for the size drill bit that I need. Put a little bit of cutting oil on here. Now it isn't actually marked on the print how deep I need to go, although it looks to be slightly longer than 0.625 of an inch, 5/8 of an inch. So I'm going to use some markings on the tailstock right here. And the tailstock itself to make sure that I have a good starting point, and I'll go a little bit more than 5/8 of an inch. Now if you noticed on the life-size part, or on the print, there's actually threads inside that hole in the middle. And this we can do on the lathe too. In fact, we can do it off the lathe, but I'm going to use a tool called a tap, like this, which is a cutting tool for threads. I'm going to put it in this holder right here, and I'm going to use the tailstock to help me line it up so that it's centered on that part. I'm going to do this. Push that in here like that. Yeah. Put a little cutting oil on there. And the tap, when I rotate it around, has dozens of tiny little teeth that are going to carve out. Yeah, that is not on your test, by the way. It's called a tap. It's going to carve out the threads on the inside of that part. Lock that in place. And once I get it started, I can take the tailstock out of the way. And just unscrew it once I've carved those out. Got some itty bitty threads in there. Okay, and now I'm almost done. I have a little notch that I need to make, and then I need to cut the end of the part off. And I notice that the end of the part is at 740, and I am currently at 777. So I'm actually going to just eyeball this one until I get it right. Probably some better ways to do that. We're going to make a facing cut just on the surface that's left. Gone a little too far there. $739, $740, going went a little too far. I went 1,000th too far. But we're almost there now. If you notice, the actual part has a notch, and that notch is 0.075 of an inch wide. And I have a cutoff tool that's pretty close to that. It's just a little bit bigger. And it is 0.625 from the end. So I'm going to set the depth gauge of my calipers again at 625. Tighten them up. And I'm going to use them as a guide to line up where I want this cutting tool. So I'm going to put it right down here like this. I'm also going to do the same thing on the overall length of the part, which is 0.890, 890. Now before I actually cut this off, there are two small things left that I want to do. The first one is if you look at that actual part, or you look at the drawing, it has these ridges right here along this part. It's called a knurl. Again, not another term that you need to remember, but that helps you grip that and turn that. And I'd like to be able to put those on this part right here. So I have a tool that does that. It's got that same shape, like this. And basically what we're going to do is we're just going to bump this up against that aluminum, that soft aluminum. We're going to force it to take that shape right there. So I'm going to drop this in the tool holder, turn this on, I'm going to slow it down. You can see we have those little ridges on it now. That's a handy little tool for that. Then the last thing that I'm going to do before I cut this off is I'm going to come in and I can feel these sharp edges where I've sliced those surfaces. And I really don't want that. So I'm going to take a file held carefully in two hands and I'm going to put just a very slight bevel on those areas right there so that there's no longer a sharp edge. And if you look closely at this part, you'll be able to see that they did that as well. It's really noticeable in particular up at the top of the knurl, right there. And that makes it look much neater and nicer to hold. So we'll spin this, up again in speed. Okay. We're going to finish.